In this last section of the challenge, we're going to learn how network policies work and why we should use them. This is the diagram of the solution. And so let's take a look at all of the microservices that we have running on my own namespace. So we have basically 6 microservices: front-end, Auth API, users API, TODO's API, Redis, and also log message processor. Now we can see here that the front end needs to access TODO's API and Auth API. Auth API should only receive traffic from the front end and access users API. Users API should only be accessed by the Auth API. And then on the other side, TODO's should only be able to communicate with Redis and receive traffic from the front end. Redis should be receiving traffic from TODO's and log message processor. And finally, log message processor should only be able to communicate with Redis. So even though all of these services belong to you, the best practice is to lock down your environment as much as possible. So if the front end does not need to talk to the log message processor, then you need to have something in place to prevent the traffic from going from the front end all the way to the log message processor. In the same way, if the TODO's API doesn't need to communicate with the user's API, why would you allow it, right? So really what we're looking to do is to only allow the services to communicate with other services that it really needs to communicate with. Otherwise, the traffic should be completely blocked. And that's exactly what network policies can help us with. So in the last section, we're going to be writing network policies definition for each one of these 6 microservices. And as always, let's start with the front end. So I'm going to create a file called network policy. Okay, the API version is very similar to the Ingress, so networking k8s.io/v1. The kind is going to be network policy. Metadata, we're going to assign a name, which is going to be front end. And then namespace is going to be my namespace. Then we have the spec. Okay, now let's break this down. So when I deploy this network policy, I need to tell Kubernetes that I want this network policy to apply to all of the front-end pods. And remember when we deployed a deployment and service, we used a selector. And we used labels to tell Kubernetes which pods should be behind the service or be controlled by the deployment. So for network policies, there is something called pod selector. And then after that is very similar, so match labels. So this is similar to deployment. Match labels, and then the label is going to be app front end. Then after that, we can define policy types. There are basically 2 policy types that we're going to be working with. And these are Ingress and Egress. So Ingress is when the traffic is coming in. Egress is when the traffic is going out. For the Ingress, because the front end is a public service, just to make things easier for us, we're going to say the traffic can come from anywhere. And here, if you want to log this down even more, you can say that you only want the traffic to come from the controller, but I just wanted to show you how you can define an ingress that allows traffic from anywhere. And this is how you would do it. So you would specify empty brackets. Then after that, we need to lock down the egress. Now, we know that the front end should only have access to the Auth API and to the TODO's API. So just to show you again on the diagram, we've got front end in the middle, and then Auth API on the right, TODO's API on the left. And when the traffic egresses from the front end, it should only go to the Auth API and to the TODO's API. And so basically here in the egress section, we have 2. So egress 2. And egress 2, you can either do a namespace selection or a pod selection. We want to select a pod selection because we want to be very specific to which pod within that namespace is going to get traffic from the front end. So that's why I'm going to specify pod selector instead of namespace selector. And again, match labels should be app. And we're talking about the Auth API, so app, Auth API. Now the port should be whatever port Auth API is listening on. So I can define the protocol. So I'm expecting to be TCP protocol. And then the port, if you remember, is 8081. So basically every time a traffic leaves the front end, it can only go to a pod that has a label app auth API, and the traffic, it would only be accepted by that pod if I'm sending to 881. All right, so now let's do the same thing for the TODO. So again, I need a to. The rest is going to be the same, so I'm just going to copy from here. So pod selector match labels TODO's API. And then ports, forgot the colon. Ports, the protocol should be TCP, and the port should be 8082 in the case for the TODO's API. So there are only two pods or set of pods that can receive traffic from the front end. And that's it. So let's deploy and see what's going to happen. So now I can do kubectl, get network policy, team1. And I see here the front end, and the pod selector is app front end. Now let's just do the same thing for the Auth API. So the first part is going to be very similar. That's why I just pasted here. The metadata name is going to be Auth API. Match label is going to be app Auth API. And we're going to have two types of policies, Ingress and Egress. Let's see how the Ingress is going to be different. So Ingress, and remember that from the front end, I did this because I wanted the traffic to come from everywhere. But for the Auth API, we're only expecting traffic to come from the front end. So I need to do from, so ingress from, and the same thing we did before, pod selector, match labels, app front end. And then I also need to tell which port I'm expecting traffic to come in. And the port is going to be 8081, and the protocol TCP. So that means it can only receive traffic from the front end on port 8081. All right. Now egress, I know that, let's go back to the diagram. The Auth API should only egress to the user's API. So back here we have two, and the rest is going to be very similar. Now the pod selector is going to be user's API, and the port is going to be 8083. And I just need to be careful with one thing. So labels need to be uppercase L, not lowercase. So let me just fix this. And I think we're ready now. So let's deploy that. For the TODO's API, this is the policy. And basically I'm saying that it only accepts traffic from the front end on port 8082. And it can only send traffic to Redis on port 6379. Okay, has been deployed. Then user's API is going to be a little bit simpler because it can only receive ingress from Auth API on port 8083. And I don't have to define egress because the user's API does not send traffic to any other pod in the cluster. So you see that under policy types, I only have ingress and not egress. Okay. For log message processor, that's also an easy one. And for log message processor, it does not receive traffic from anything. It only communicates with Redis. And that's why the only policy type that you see here is egress. So it can only send traffic to Redis on port 6379. Now finally Redis. And with Redis, it can only receive communication, but Redis itself does not start communication within other pods. That's why you only have ingress. But now take a look at the pod selector. So under match labels, we have Redis access true. And that's exactly why we set that label in the beginning. So basically in our case, we have TODO's API and log message processor that needs to be able to communicate with Redis. And so to make things easier, we assign a label to these two different pods, and we're using that label here. If there was any other pod that would need access to Redis, you would have to assign the label Redis access true to this new pod. So then basically here, every single pod in the cluster that has the label Redis access true can communicate with Redis on port 6379. So now let's deploy this. And there it is. And now if I get network policy, I have 6 network policies, but there is something missing. And let me just demonstrate to you. So get pods, team 1. So I'm going to go inside Auth API. And I have curl here. So if I try to curl users API on port 8083, it's not going to work. Even though we gave access to Auth API to the users API, it's still not going to work. And this is our clue. It says it cannot resolve the host users API. So it's not even that users API is not receiving the traffic, DNS is not working. And that's exactly what we missed. So we were only worried about each one of the pods being able to communicate with each other, but we forgot the most basic thing, which is DNS. So basically what needs to happen here is that we need to have an egress rule that allows each one of these pods to send DNS queries through port 53. And that's the last step. Now I could add an egress rule to each one of these services, but think if you had 100 services, you would have to change a lot of code. So what we can do is we're going to create a separate network policy that is going to apply to all of the pods. And then you're going to see something different in the pod selector. So outside all of the folders, I'm going to create a DNS network policy.yaml. This is the network policy for allowing DNS access. So the name is allow DNS. It's going to be deployed in my namespace. And basically what I'm saying here is that every single pod in my namespace should be able to send traffic TCP or UDP to port 53 to resolve DNS queries. That's basically what it is. And this is the last thing that we need. So let's just deploy that. Okay, great. So if I try to get network policy on my namespace, I should be able to see allow DNS. And let's just go back to the Auth API pod again and try to run the same command. And there it is. We're able to access the users API. So just to make sure that everything is still working with our application, I'm just going to go back to the browser and try to interact with the application a little bit. So again, this is our TODO application. So I'm going to try to log in. And the front end should be able to talk to the Auth API to log me in. And I should be able to see the list of to-do items. And there it is. So everything seems to be working fine, even though I added a bunch of network policies. And that was really the last step of the challenge. So I hope you had fun. The content of this CTF, this challenge is going to be on GitHub. So take a look at the description of the video below. So if you try to run this yourself and you run into trouble, please feel free to reach out to me on Twitter. So thank you for following along. And I'm already working on the next challenge just like this one. So stay tuned.